In the previous video we defined what an atom and an element were. I've linked the video in the description. Let's apply this knowledge to how atoms behave in the real world. To help understand this, we will need to define molecules and compounds. Let's start off with reminding ourselves what the definition of an element is. An element is a substance made up of atoms that have the same number of protons in their nucleus. In the real world, we are not lucky to only deal with elements. Elements can mix and match and create new substances called molecules and compounds. Let's start off with molecules. A molecule is the smallest particle of a pure chemical substance that still retains its composition and chemical properties. A confusing definition. Let's simplify. A molecule can be thought of as a group of atoms stuck together, at the minimum 2 or more atoms held together, usually through chemical bonds. Let's take an example of oxygen. This is a single atom of oxygen. However, elemental oxygen goes around in pairs of atoms, or O2 that are bonded together. So these will be called a molecule. Another example would be chlorine and also nitrogen. Although these examples contain just one element, molecules can contain a variety of elements bonded together. A good example is water, which contains 1 atom of oxygen and 2 atoms of hydrogen. Another example would be carbon dioxide, which contains 1 atom of carbon and 2 atoms of oxygen. If we take helium, this would not be a molecule, as it only exists as a single atom, and we know a molecule requires 2 or more atoms. Let's take a look at compounds. Compounds are made of 2 or more different elements, and they contain 2 or more kinds of atoms joined together, and these are held together by chemical bonds. Some of the molecules we mentioned can also be considered as compounds. Here we have as an example of a compound water, which contains 1 atom of the element oxygen and 2 atoms of the element hydrogen. So this compound contains 2 elements, oxygen and hydrogen. Carbon dioxide contains the elements of carbon and oxygen. So this is another example of a compound. The molecules of chlorine, oxygen and nitrogen are not compounds, as they are made up of atoms of a single element. Another principle of compounds are that when compounds form, the atoms of each element within the compound are of fixed proportions throughout the compound. So if we take water as an example, it always has 1 atom of oxygen and 2 atoms of water. Just like elements can be represented by symbols, compounds can be represented by formulas using their chemical symbols. So for water, we could represent the formula as H2O, where the 2 is written smaller and lower in subscript, showing that there are 2 hydrogen atoms in the molecule, and since there is only 1 atom of oxygen, we would not write a number. Let's take a look at carbon dioxide. For carbon dioxide, we can represent this in the formula CO2. There is only 1 atom of carbon, so we would not write a number in subscript, whereas there are 2 oxygen atoms, and the 2 is written in subscript, showing that there are 2 oxygens in the molecule. Compound formulas can get more complex. Let's take the example of H2SO4. Here we have introduced new symbols. If you are unsure what these mean, we can always look in the periodic table, which will have the symbol and full name. So H represents a symbol for hydrogen, S is a symbol for sulfur, and O is the symbol for oxygen. The name of this molecule is sulfuric acid. It contains 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen, giving this compound. Let's look at another example, AlOH3, aluminium hydroxide. So Al represents aluminium, O represents oxygen, H is for hydrogen. The brackets are used to group everything inside them, and the number on the outside, which in this case is 3, tells us how many of those groups there will be. So we have 1 atom of aluminium and 3 groups of OH. Let's look at another example, CaOH2, or calcium hydroxide. Ca represents calcium, O represents oxygen, and H represents hydrogen. The bracket is used to group everything inside them, and the number on the outside, which in this case 2, tells us how many of those groups there will be. So here we have 1 atom of calcium and 2 groups of OH. Compounds get extremely large. The examples we have seen contain only a few atoms, but some compounds contain anywhere from millions to billions of atoms. Let's take the example of normal home salt, also known as table salt. Chemical name of sodium chloride with the formula of NaCl. This is a relatively simple compound based on the formula. It has 1 sodium and 1 chlorine atom. But in reality it forms massive structures containing billions of atoms. How this happens we will cover in another video, but in summary these large compounds are formed by a concept of ionic bonding, essentially bonded based on opposite charges. Making bonds involves atoms giving away, taking or sharing electrons. The nuclei of the atom are not affected when a bond is made, only the electrons are involved. As these are such large compounds, we do not define these as molecules, rather these are non-molecular compounds. So why are formulas of non-molecular compounds important? They help us understand the ratio of elements of the compound. So for NaCl we have a 1:1 ratio. For every 1 sodium atom we have 1 chlorine atom. So if you pour some salt on your boiled egg, you may have a billion sodium atoms, but you will also have a billion chlorine atoms. Here are some handy formulas and their names to remember. So first up we have NH3 with a chemical name of ammonia. Then we have CO2 with a chemical name of carbon dioxide. CO with a chemical name of carbon monoxide. H2SO4 with a chemical name of sulfuric acid. H2O, chemical name of water. HCl, chemical name of hydrochloric acid. CaCl2, chemical name of calcium chloride. HNO3 with a chemical name of nitric acid. Na2CO3 with a chemical name of sodium carbonate. NaCl with a chemical name of sodium chloride. Let's go through 2 questions. First question is, how many atoms are in 1 particle of Na2CHO4? There are 2 sodium atoms represented by the symbol Na, and it has a subscript of 2, which means we have 2 sodium atoms. We have 1 carbon atom shown by the symbol C. As there is no subscript, we know it's a single carbon atom. We have 1 hydrogen atom shown by the symbol H. Again, no subscript, so there is only 1 single hydrogen atom. And there are 4 oxygen atoms represented by the symbol O. And since it has a subscript of 4, that's why we know it's 4 oxygen atoms. Next question. A compound has the formula Na2CO3. Name the compound and the elements it contains. So the compound is Na2CO3, and this is called sodium carbonate, and it contains the elements of sodium, carbon and oxygen. That's all for this video. Hope you found this useful. If you did, please give a like and subscribe, and I will see you in the next video.